Good morning, everyone. My name is Nanette Ho-Covington. I'm the Executive Director of the ETC Foundation. So welcome to our floor. Welcome to day two of Canada Climate Week Exchange, so CCWX. And today it's being hosted by PTAC and CRIN. Wanted to mention that there's lots of things going on, and welcome to come back the next couple days as we have lots of events. But CCWX is a national initiative that brings Canadians together for 1 week each year to collaborate on solutions to our country's unique climate challenges. This week is about accelerating made in Canada solutions and that will strengthen our economy and communities and environment. But first off, I want to acknowledge the land that we're on. In the spirit of respect, reciprocity, and truth, we acknowledge that we gather on the traditional territories of the peoples of Treaty 7 in southern Alberta. This includes the Blackfoot Confederacy, comprising of the Siksika, the Kainai, and Piikani nations, the Tsuut'ina, and the Îyârhe Nakoda nations, consisting of Chiniki, Bearspaw, and Goodstoney. We also recognize that Calgary is home to the Otipemisiwak Métis government of Métis Nation within Alberta Districts 5 and 6. We honor the original caretakers of this land, known as Mohkinstsis in Blackfoot, and acknowledge all Indigenous and non-Indigenous peoples who live, work, learn, and play here. May this acknowledgement remind us of our shared responsibilities for reconciliation and to build respectful relationships with Indigenous communities. Just a couple housekeeping things before we begin. I turn the mic over to Lauren. Just to let you know, in case of emergency, you'll hear the alarm. You'll find staff directing you, but the muster point is on the west side of Centre Street on this side. And washrooms, just to let you know, the men's is down there. You don't need an access card, but for women, we do need an access card because you do exit and enter the hallway. And the access card should be on the little black table over there. And if not, I don't see them there, I'll go find them. I think that's it. I'll turn it over to Lauren.
Perfect. Thank you, Nan. Yes, I was pointing out. Perfect. Good morning, everyone, both here at the ETC and joining us online. Welcome to Canada Climate Week Exchange, a session on practical climate solutions, PTAC-enabled success stories. So I'm Lauren Savoie. I'm the President and CEO of PTAC, the Petroleum Technology Alliance Canada. So for you that do not know us, PTAC is a 29-year-old neutral, nonprofit, industry-led facilitator, and we're a hub for the oil and gas industry. We facilitate research, technology development, and deployment. So we have 3 sessions or 3 panels planned for you today. The first one is Canada-wide innovation collaboration. The second is innovation in advancing technology in the real world, an OPERF story. And then third, we have global uptake of Canadian climate innovation. So without further ado, let's jump into our first panel. So the Canadian-wide innovation and collaboration session dives into power of partnerships, how industry, academia, and government can work together to accelerate clean energy innovation and drive meaningful emissions reduction. We'll explore 3 key themes. We're going to explore national collaboration, applied research deployment, and global innovation uptake. So we are very thrilled to be joined by our incredible panel. We have online Dave Finn. He's the CEO of Energy Research and Innovation, Newfoundland and Labrador. We have Mike Crabtree online. He's president and CEO of Saskatchewan Research Council. And then here in the room, we have Justin Reamer, CEO of Emission Reduction Alberta. And we have Neil Wildgust, President and CEO of Carbon Management Canada. So it's my job here to facilitate online and here. So we're really looking forward to it. So let's dive in. So to kick things off, here's a quick warm-up question to all 4 of you. If you had to describe Canada's clean tech innovation ecosystem in 1 word, what would it be and why? Let's start off with you, Justin.
Well, I would say powerful. Now people go, well, that's an easy word to come up with. But what I've been able to experience in my 3 years as CEO of Emissions Reduction Alberta and see the leverage of both the expertise, the infrastructure, the talent within Canada and in the clean tech space, and how the ecosystem has wrapped itself around supporting a lot of these innovators from going from bench to deployment and commercialization has been extremely powerful. Not enough Canadians realize what's actually been happening in this country around clean tech and the many success stories that we've seen.
Perfect. Powerful. Neil.
I agonized over what this one word should be for quite a long time. I'm going to go for chaotic. From my vantage point, running a non-profit applied research organization, the funding environment and the whole landscape is really difficult to navigate. And money is a constant challenge for us as a non-profit. So we've had a good year. We've won $14 million of grant money this year with partner organizations. But things are still financially challenging. And I'll probably get more into that with some of the other answers.
Perfect. Mike.
So I had two words, and I'm going to say first word is translational, and why? Because Canada excels at generating ideas and IP, but the real opportunity is translating those ideas into deployable, scalable industrial solutions. And I think a challenge is that often our innovation ecosystem, and this is, I think, mirroring what Neil's just said, is more like frog spawn. So my first word was going to be frog spawn, and it's more like frog spawn than a navigable invention to innovation ecosystem. So those would be my words: translational on the good side, and frog spawn on maybe not such a good side.
And then last but not least, Dave.
Yeah, thanks, Lauren. Hi, everybody, virtually. I struggled over this as well. And I think my job here is to bring a little bit of an East Coast offshore perspective. So I won't comment on the national scene as much, except how we fit into it. But the word that I came up with is emerging. I think for decades in the offshore here, we've been looking at marine sound, oil spill response, fate and effects of drill cuttings, et cetera, et cetera. But the clean tech emissions, that kind of definite, depending on your definition of clean tech, is really new here, and it's been kickstarted by some of the funding that came out of the Emissions Reduction Fund. And there's a lot of exciting things going on here, but from my perspective, we're pretty small compared to the rest of Canada, and I'll stick with that word, emerging.
Okay, so our four words are powerful, chaotic, translational or frogsborn, and emerging. So let's dig into that a bit further. So national collaboration. Canada just launched its climate competitiveness strategy, emphasizing collaboration across provinces and sectors. As everyone knows, Canada is vast and diverse. So, question, what's one collaboration model or partnership your organization has found most effective in breaking down regional silos and accelerating innovation? Justin.
So ERA has an interesting partnership model that's evolved over our 16-year history, and what we call it is our trusted network. There are a lot of players in the ecosystem supporting clean tech innovation. And what we have is a sort of standard MOU that we develop with a variety of different partners, some of which you hear or see about today, including PTAC. We have partnerships, trusted partnerships with NRCan, with a variety of other venture capital firms focused in the area. And what we do with these trusted partners is we have a confidentiality MOU, and we share due diligence very often about proponents that we're evaluating for funding. And through that process, we can save other entities a lot of time because we've done our due diligence, we've had funding experience with those proponents, or vice versa. They've had the same. We have a very good trusted partnership with NRCan. And we have co-funded a number of companies together, and we've learned from one another what the company's strengths, their weaknesses, their gaps, and how do we work together rather than operating in silos. And then we facilitate that enhanced funding leverage. And it also saves the company a lot of time because they don't have to answer reams of questions for both all of these funding entities at one point. We're actually pursuing a partnership with NorthX in BC as another funding entity for low emissions technology development. So that trusted partner network we've established has worked very well for us.
Perfect. Neil, what's one collaboration model or partnership you'd like to talk about?
Well, for us as a non-profit and a relatively small company, we have about 20 staff. Collaboration is absolutely vital. Without that, we don't exist, and we don't really have a reason to exist. So we have an industry partnership. We call it the JIP, Joint Industry Partnership. We have 23 companies who all put either money or cash or in-kind support into our program. We inject relatively small amounts of carbon dioxide out near Brooks at our Newell County Field Research Station, and that's used as a test bed basically for monitoring technology and developing monitoring technology for storage. So we really operate that with a classic consortium model, so that we need government money. We have industry partners who are happy to leverage against that government money. That's part of the value proposition for them. And then government is happy, or funding agencies are happy, because they see that we're not just academic, we have industry support. And that kind of consortium model, I think, is getting harder and harder to secure the money for. And that's sometimes a source of frustration for us. We're very grateful to Justin and ERA because they've been a tremendous supporter in the last year or so, and we have a grant with them. And that's really, at the moment, our main technology value proposition moving forward. So that collaboration model, I think, is really important, of having government funding and industry cost share.
No, thank you. Dave, what's one collaboration model or partnership your organization has found most effective?
Yeah, I mean, I was nodding along there as Neil was talking, and I mean, we're an organization that is owned by 6 oil companies that are all producers in the Newfoundland, Labrador offshore. So we've got a kind of a built-in collaboration platform, and that multi-industry multi-partner funding and JIPs is extremely effective for us, and it's been our kind of backbone for years. The government funding for us, because our funding is somewhat constrained geographically due to benefits agreements, the government funding is really essential for us to work outside of our regulatory imposed silo. And one in particular that hasn't been getting a lot of love necessarily in Canada is the cluster model. We were very involved in the Ocean Supercluster, and lots of our proponents take advantage of NSERC and IRAP and MyTax, et cetera, and that's driven by the proponents. There's one professor that knows somebody in University of Calgary, et cetera, and they work together to build the proposal. So that's a kind of a proponent-driven collaboration model. What we did find with the Ocean Supercluster is that we were involved with other industry partners in kind of shaping the themes and the technology focus areas, and that was really helpful. We had some very big projects come out of that. That broke down some regional and national silos for us. So I'll give them a bit of love. But again, government funding that's, can be influenced by industry needs, I think is critical.
Perfect. Mike.
So our collaboration model is somewhat different. SRC's been in existence for about 76 years. 1947, I think we were started. So we're government owned by a province of Saskatchewan, wholly owned, but we are for profit. So our collaboration model is to work directly with industry. So give you some indication of that on our funding. So our revenue ranges from about up to about $150 million per year, of which $20 million comes directly from government. So we're very reliant on working directly with industry, and we work with some 1,500 clients across 22 countries. So that is our model. Our model is to operate at the leading edge in the 5 industrial sectors that we operate, everything from mining and minerals through to nuclear and things like rare earths. In fact, rare earths is a really good example. We're just completing our rare earth processing facility. It's the first of its type in North America, and that is a collaboration between industry, universities, indigenous communities, some support from federal government, but primary support from our own province. So it's about SRC acting as a catalyst, as a driver, and then delivering what industry is looking for, which is commercialization. So we consider ourselves to be a research, development, and commercialization organization. Research with a relatively small R. We do research where it's necessary for us to for specific projects. Development with a bigger D, but with commercialization with a very big C. That's what we find as something that generates that sort of patient, consistent funding that we need in order to be able to drive these larger projects forward.
No, thank you. I have another question if one of you or two of you would like to answer. If you could design a dream collaboration across provinces or sectors, what would it look like? So I will direct, or
I'll jump in
I
this
forgot
one.
we have on, and we can do Dave there. Yeah.
Yeah, well, I started, dreaming about quantum computing or robots, etc. And I wanted to bring it back to enabling dream collaborations a little bit and throw this out. And this might get into collaboration models a bit, but I've got kind of three points I want to make here. One is that program supports governmental funding needs to be scalable to support these kinds of national collaborations. And the example that kind of echoes mostly for me is the SIF Net Zero Accelerator. You needed to have large projects financially. That wasn't necessarily as big a problem for us as it was the absolute emission target that they wanted to have each project address. So there was 1 million tons of emissions reduced. Well, we've only got 2 million tons at most in our region, so we couldn't access that funding program, although there were things we wanted to collaborate on. So scalability of funding programs. The second big challenge is finding more alignment on technical challenges. I think that's a real challenge for offshore and onshore in Canada because we do have different problems. So having more time to find those kinds of alignments. And the third big challenge is geography. Networking, collaborations come from relationships, and we really are a big country that it's not easy for people to get back and forth between Newfoundland and Calgary or BC as an example. So my dream program would be for the federal government to offer some kinds of supports or industry to find supports that would address each of those. So I don't know exactly what that looks like, but something as simple as travel supports, more workshops and networks where we make the effort to get folks back and forth between different regions of this country, I think would really help. I think that's important. And we're working on that. We'll always try to have workshops where we can bring people from around the country. So I think those three elements would unlock some more dream collaborations. Bit of a soapbox, but
That's good. Thank you. How about yourself, Neil? You look like you want to answer.
Yeah, I have a soapbox here as well. I would love to see a coordination of the geological storage pilot sites across Canada, whether that was dubbed as a center of excellence or a network or however it was done. We have our operation out near Brooks. PTRC has the Aquastore project across the border in Saskatchewan. There are other small geological pilot projects being planned, and these things have their own advantages compared to commercial deployment. They're obviously ultimately there to support commercial deployment, but the difference is that we can do knowledge sharing. We can have visitors at our site out near Brooks. There's no commercial sensitivity, even though we have all the state-of-the-art monitoring technology. And people, whether they're lay people or technical experts, always enjoy when they come to the site, having a visit, hearing about what we do and understanding what we're trying to do with monitoring technology. And geological storage is taken for granted when you're thinking about CCS. Everyone is understandably obsessed with the cost of capture and policy. But geological storage is not a done deal at very large scale. There's still a lot of work to do, and that gets overlooked. And we think, and both myself and my counterpart in PTRC and others, I think we would love to see more of a coordinated approach across provinces to showing that geological storage is safe and reliable and is going to take the kind of tonnage that is relevant to emissions reductions. But the frustration here is that it's very difficult to get NRCan interested in an idea like that. And that's been a particular frustration of mine in my job for the last 2.5 years. So I think that dream collaboration for me would be working across Canada to show that this essential element of CCS, which we need, really works and can accommodate the kind of volumes we need. But that in my opinion, that requires significant federal support, and that, as I've seen so far, is just not there.
I'd echo just what Neil said there. I think there is a real need for a unified platform on particularly on CCS, and I agree it's something that's very difficult to get NRCan engaged with. The other piece I would say, it's slightly different but related, is in the way that the federal government funds the development of technologies from inception through to commercial application. You have to go through multiple stages and multiple different programs to do that. So for small companies that are looking to engage with this technology, they fall between these funding gaps. And having a more unified approach to taking technologies from TRL level 1 right through to 9 would be something that I would see as part of that sort of dream collaboration.
I can just pile on.
You bet.
So, given what Neil said on the storage, that's absolutely true and be fantastic. From my mindset, capture and the next generation of carbon capture technology is key to unlocking the economic viability of CCS. And it requires a national approach. So one version of a dream collaboration would be federal government, for ERA, for a variety of provincial funding entities to put money pooled together into $100 million next generation carbon capture program, like an X Prize type competition. And in so doing, ensure access to industrial sites as well, because that's a huge limitation. So Alberta could have an oil sands company giving opportunity to do this demo. Another province could have a power generation to do a demo in a different instance, and facilitate sort of that national X Prize approach to next generation capture. I think would be very exciting and absolutely necessary if we're going to see CCS scaled in a meaningful way.
No, sounds good. So National Unified Platform for CCUS is what I'm hearing is the dream collaboration. And then the models that are working are trusted partners, joint industry partnership, cluster model, and directly working with industry. We're going to do a couple of direct questions. Of course, we always have really good content, so we're going to try and make them a little shorter. But Dave, Newfoundland and Labrador faces unique offshore and remote energy challenges. How do you see national collaboration helping to scale solutions from your region to the rest of Canada?
Yeah, so I guess, Lauren, I should take 30 seconds and describe the offshore here for
definitely.
folks that don't know. There are 4 producing assets offshore Newfoundland and Labrador. They're all between 300 and 350 kilometers offshore in the North Atlantic. The production is relatively small compared to Western Canada. We've averaged, between 200, 300,000 barrels a day over the past few years. Totaling 7,500 million barrels per year in production. That environment that you referenced is one of the harshest marine environments in the world. Anyone from the industry who comes there says it is the harshest. We've got sea ice and icebergs which need to be managed. But probably the bigger challenge is the extreme winds and waves and storms that we experience. Really narrows operating windows when you've got sea states, consistently in the 5 and 6 meter wave heights. So with all of that, some of that is and fog, by the way. Huge challenge for logistics and helicopter operations, and adds tremendous expense to production here. So some of those challenges are not totally relevant to most of Canada. I would think of that in the north, a lot of it is pretty relevant. One of the ways we've been trying to reduce our environmental footprint consistently over the years is around efficiency. Again, we've got assets that are not connected to a grid. It's very difficult to deploy mass, new technologies to you can't swap out generators, et cetera. These are big brownfield assets. So a lot of the work and focus for us in the industry here has been around efficiency and leveraging digitalization, remote operations, use of robotics and autonomous systems, onshore control. A lot of that capability is really exploding here, and that is extremely relevant to, I think, remote mining operations, et cetera, northern operations, the defense sector. So not relevant to our climate challenges, but on the defense side of things, there's tremendous overlap between what Canada is aspiring to do in our Arctic defense, et cetera, and what the offshore industry has been doing here and continues to invest in those capabilities. So I think that's probably the kind of area where we can deploy and support the innovation across Canada.
No, that makes sense. Defense for sure. Mike, I have a question for you. SRC has deep expertise in applied research. How do you ensure the research outcomes translate into real-world deployment across Canada?
Yeah, I think it's worth just giving a real quick overview as to what SRC is involved in. So we have a number of divisions, large divisions, so an environmental, a minerals, a mining, energy division, which is oil and gas through to renewables, and then special projects, rare earths and micronuclear. So SRC, we're unapologetically applied. Our focus is TRL levels 3 through 9. And we start with the industry problem, and we build the research, development, and commercialization program around that. We bring industry in from day one to co-design the projects and the technologies that we're looking at, with the intention of demonstrating those technologies at scale, validating 3 things: the technology, the market, and the economic viability. We have very little interest in working on technologies where we can't see a route through to commercial adoption. We look to prove it in Saskatchewan and then replicate and transfer those models across Canada and actually across the world. As I mentioned, we operate 1,500 clients in 22 countries. Our sort of little mantra is flexibility, ability to pivot to rapid market changes. And so we, research, development, adapt, and adopt is the approach that we take. But if we cannot get industry interested at a very early stage and bringing real funding in, then that's a big red flag for us.
No, you definitely need the industry pull in order to move things forward. And I like the flexibility and ability to pivot too. We've covered one of the 3 topics, so we're going to jump. So we might speed through some of these here and get to some of the fun ones. But we've talked about collaboration. So now let's dive into how research becomes a reality. So we often hear, and I think it's talked about a bit before yesterday, about the valley of death between research and commercialization. What's one bold idea to bridge that gap faster? Let's start with you, Dave.
Okay, I can talk really fast, Lauren, if you want me to. I was
if it's legible, yeah.
That's right. So, okay, I'll throw out test beds and particularly regulatory sandboxes to bridge that gap between innovation and safe deployment in a challenging environment. I think we've always all had test beds and labs, et cetera. one of the things on the digital side of things that's probably going to come, which could be pretty interesting, is if you have AI models looking at regulatory compliance and can we accelerate scenario modeling, et cetera, simulation of outcomes, can that help regulators approve things faster? I'll throw that out.
Oh, sounds good. Test beds and regulatory sandbox. Mike.
Yeah, as most of us know, that there's not just one valley of death. There's a number of discrete valleys of death between that TRL level 4 and 8. And here in Canada, we're very good at funding research projects, and we're not bad at funding commercial projects that have largely gone through their valleys of death, but not the industrial scale pilots between. Comes back a little bit to what David was saying there, that we need to have a dedicated funding capability to take those promising projects through those very, very difficult processes. We lose a lot of what would otherwise be significant commercial technologies because they simply run out of money, they run out of funding. And, the federal government, to an extent, the provincial government sees them as high risk. And it's almost, you're on your own. If you can navigate between 4 and 6 and you survive that, we'll see whether we're going to talk to you on the other side. And I think that being able to bring in some dedicated support there would be very, very useful.
That sounds good. For you two, I have a different question. What's the most surprising lesson you've learned from deploying a clean tech solution in the field? Justin.
Nothing ever goes according to plan. Nothing. We have monitored several different technologies. We've had 300 technology projects in our portfolio over the past 16 years. Of the 175 that actually completed, half of those have commercialized. So we think that's a very good success ratio in terms of taking bets, funding promising technologies, doing the evaluation, and helping them navigate. But we are constantly amending contribution agreements, changing milestones, changing financing landscapes, changing timelines, changing goalposts in many instances. And that's absolutely required when you're funding technology. It's not a straight point A to B. It's a big zigzag and twirl before you get to B. So you need the tech innovators need that flexibility from the funders to understand that, again, nothing goes according to plan. It's good to have a vision and a plan, but then when you have to pivot and adjust, as Mike was saying earlier, and it always happens, you have to have the responding funders, regulators, other evaluators understanding that those pivots are necessary and how to adopt to change market circumstances.
So I think for me, CMC, I'm a CCS person, as you probably already understood. And when I took this job, CMC, we're focused on CCS and storage, but we do get involved in other things when it makes sense. And one of those has been fugitive methane monitoring. And so we've been jointly with our partners, SPOG, we've been running a Alberta methane emissions program for the government here. And that's been quite a big project with a lot of alternative monitoring technologies tested, and including at our field site, we have a controlled release facility. And, when I first got involved in this, I was a little bit snobbish as a subsurface person. I thought, well, isn't it just a plumbing problem? You find the leaks and fix them. And it didn't take very long for me to realize that the problems are a lot more complicated than that. And all of the fugitive emissions monitoring technologies have their advantages, but their weaknesses as well. And it's really challenging to reconcile what we can measure with more broad-based surveys like satellites, planes, etc., with very specific monitoring technologies on the ground, men with cameras, robot dogs, you name it, we've had them all. And so getting these things to mesh together to form a holistic view of what's happening with fugitive methane is really, really challenging. And the allied challenge to that we've also experienced is data quality. So we've collected vast amounts of data in the AMET program. I think we've covered something like 10% of all Alberta's upstream oil and gas facilities where testing has happened. And inevitably, the data that comes back from the operating companies is wildly different in quality. And so it's taken a huge effort on the team's part to actually, we now have a public-facing data hub online. Then you can find that very easily if you Google AMEP, AMEP. And we're very proud of the data set that we're building up because it's fairly unique. But the effort that's gone into that is huge to make sure that the data is of sufficient quality and robust enough that you can sensibly use it.
So I think for the valley of death, nothing is as easy as it seems, which is kind of in its terminology there. And pivot and adjust is some of the key pieces there. Neil, Carbon Management Canada is at the forefront of emission monitoring and storage. What's the next big leap in carbon management that Canada needs to lead globally?
It's a really broad question, but I think the thing that comes into my mind is well, fugitive methane. Actually, we have great opportunity because we've collected some fantastic data sets already in Alberta, and I think Saskatchewan and BC are in a similar position. But talking on the CCS front, I mean, we do have an opportunity if the commercial case can drop for the Western Canadian Sedimentary Basin to be maybe the first location in the world where we have multiple large-scale storage projects. And I think that's a tremendous opportunity for Canada to show that this is the most robust way that we can take CO2 emissions and permanently remove them from the atmosphere. And there's nothing wrong with finding ways to convert CO2 into useful products and all the rest of it. But that will never account for more than a very small proportion of CO2 that's captured if this is really commercialized. So the geological storage side is essential, excuse me. And I think we have an ideal opportunity, particularly in Western Canada, to show that at a basin scale, we can have multiple large-scale sites existing together.
Now, and one for you here, Justin. ERA funds transformative projects. What's one project that made you rethink what's possible for emissions reduction?
So there's several, but I'm going to focus on one today, direct air capture. So everyone says direct air capture is expensive, and it is. And the first one is always expensive. And the way in which you reduce costs is to demonstrate various technologies at commercial industrial scale. It looks way different in the field than it does in the lab. And that's part of our role. So one really exciting project we funded last year was Deep Sky. Deep Sky is a Quebec firm that had some funding from a variety of sources, including Investissement Quebec. We provided them with $5 million to set up an industrial demonstration, commercial demonstration site in Innisfail, Alberta. They did that. They set up this plug and play facility for a variety of different technologies within a year. I've overseen a lot of projects that almost never gets done. So that speed to market and the ability to execute and implement has now enabled them. I'm getting probably the numbers slightly wrong, but I think about 6 or 7 different direct air capture technologies are either in the process of commissioning or being installed at that site right now. And it is becoming the world's first commercial demonstration facility for direct air capture, right, just north of Calgary here. So we're very excited to see what the learnings from a lot of these industrial demonstrations are. And some very big name companies are providing their nascent direct air capture technologies to be tested at this facility. And, most Albertans, most Canadians aren't aware of that. Now, Deep Sky is talking to Manitoba about doing a project there, looking at Quebec as well. So it's a very exciting thing to monitor, and we'll see how it evolves over the next few years.
No, good. We're going to move, though, now from applied research and deployment to looking beyond Canada. How do we compete globally? So Canadian innovation often punches above its weight globally. What's one way we can better position our technologies on the world stage? Dave.
Yeah, I'm thinking about this one, Lauren. I kind of feel like I got a lame answer here, but
You're not lame.
talk about collaboration models that are JIPs. And for us, we've got built-in JIPs, which include multinationals, big multinationals who are, can bring technologies to other operating regions and make them visible, like Guyana, Trinidad, Tobago, West Africa, et cetera, North Sea. And we do see that happen quite a bit. So I think the collaboration model at the beginning is important to have international participation in, and that's something that's it's almost a strategic thing to look when you're formulating a project to have that potential international partner in big markets.
And Mike, what about from your view for Saskatchewan?
Yeah, as you can probably tell from my strong East Saskatchewan accent, I'm not from around here, so I've got a perspective of how different jurisdictions operate in the sort of global innovation space, and I think Canada actually does punch above its weight. I think sometimes as Canadians we beat ourselves up, and we actually do really quite a good job. But I think to answer the question, how can we better position ourselves? I think we need to stop presenting ourselves as just a country of great ideas and early stage pilots. We need to position Canada as an industrial proving ground and commercialization center where these technologies can be deployed in harsh conditions, complex geology, real industrial systems, and on the basis that if it works here, it can work anywhere.
No, I like that. If it works here, it can work anywhere. Some more of that promotion too, along with it. If you had to pitch Canada's clean tech story to an international investor, and I have my watch going here, in 30 seconds, what would you say, Justin?
Timey.
Yep, go. Actually, I don't have seconds on here.
Canada has the infrastructure, the talent, and the funding pools necessary to be an industrial playground for clean tech deployment and innovation. We've demonstrated CCS at scale, direct air capture at scale, all sorts of energy efficiency and extraction technologies that are now being globally adopted and accepted. Come to our country and see what can be done to move your technology from the bench to deployment.
No, that's good. And talent, definitely within there. Neil.
Yeah, I just echo that on the CCS side. We've built stuff, and you only have to go to Europe or talk to Europeans in the CCS world who still lament, excuse me, after 3 decades of talk, nothing's been built there in essence. And they have very advanced policy development, etc. But there's nothing on the ground much to go and look at. And you contrast that to Canada with Shell Quest, the Alberta Carbon Trunk Line, Boundary Dam, Aquistore, the Weyburn program before that. We've got a fantastic track record of actually achieving stuff.
No, that's good. Great. So we just need to be able to promote ourselves a bit better on that global stage. I have one question here because we have about 5 more minutes that I'd like to kind of close this off with. Is what's one Canadian innovation you think will make headlines in 2030? I am going to go around to each of you. So let's start with Mike.
I'm going to step out a little bit out of the space we've been talking about, but this is very much into clean tech and energy transition. And I think this commercial scale production and midstream manufacture of separated rare earths, I think Canada has the opportunity to be a global leader in this space for sustainable rare earths production, ex-China.
Great. Dave.
I'll throw out quantum computing and applications of quantum computing. I mean, we do a lot of stuff in the digital space, and I haven't seen, as much buzz about quantum and an explosion in people looking at applications and researching it. Still big gaps on the physical side, on the actual computing side, the hardware side. But I'll give you an example. Memorial University, with IBM's sponsorship, has attracted a Canada Excellence Research here in quantum computing, have gone from 0 graduate postdoc students 2 to 3 years ago to 56 working in quantum now. A lot of interest nationally in that. And I think it's going to start becoming real and will really be, it'll supercharge AI and simulation and solving all kinds of complex problems. And Canada's got a real opportunity to have a leadership position there. I think there's a number of big investments coming in the budget and soon to be announced around a quantum strategy and a new updated AI strategy, et cetera.
We need to make sure we don't lose the lead that we had with AI.
Exactly.
So headlines in 2030, we have rare earth, we have quantum computing. Justin?
I was going to go into the AI rabbit hole, but I will focus instead on lithium extraction from oil and gas, Brian. We funded a number of companies, including Lithium Bank, E3 Lithium, Leidos, and I was just out at the drilling rig that E3 Lithium is doing their commercial demonstration now on drilling 2.5 kilometers into the ground to essentially extract the brine and extract lithium. And I think the momentum is there. We need other supply sources beyond that. So really excited about the potential of that.
Neil, is it carbon capture?
Well, so I got two. My safe bet answer would be that by 2030, if we haven't got multiple large scale storage sites operating in Alberta, it will be a real shame. We've got such a great opportunity. But there has been some momentum lost because of policy uncertainty, etc. So it's not a done deal, but I would hope that that's happening and it's being monitored by real effective next generation technologies. But as a bit of an outside bet, and maybe 2030 is too ambitious, but I think Beck's bioenergy with CCS has a lot of potential in Canada. I'm sure there's a lot of practical and policy challenges in the way, but it seems like if that's going to happen anywhere, it seems a bit of a no-brainer that it wouldn't happen in Canada where we have such huge forestry resources. So that would be my sort of outside bet. 2030 might be a bit tight.
No, thank you. So we've gone through national collaboration, applied research deployment, and global innovation uptake. So Dave, Mike, Justin, and Neil, thank you very much for being here today and spending your time here with us. And thank you to everybody here and online for being with us. So we are going to move on to, and a big shout out, Corinne and the ETC Foundation. Thank you so much for hosting us here today too. But we are going to move on to our next panel in about 5 minutes. And it's about innovation in advancing technology in the real world, an OPERF story. So stay tuned.